Thank you very much, Maria. Thank you all for the kind invitation. It's a great honor to give this keynote lecture in your conference. And I can tell you, I wish very much to be in Portugal, to be there in person. I was recently at Photonics West in the US in January, and it was a pleasure to see all the colleagues again. And good morning also to all the colleagues I saw already, many of the names, many friends in your participants list. So it's a pleasure to report on a topic that we have been working lately on. This is topological plasmonics, and I want to show you how to watch the subfemtosecond vector dynamics of plasmonic skyrmions with a 10 nanometer spatial resolution. I should mention that this work has been carried out in very close collaboration with my colleagues from Duisburg, which is the group of Frank Meyer to Heringdorf, together with Pascal Dreher and David Janoschka. And a very important collaborator for us is Tim Davis from the University of Melbourne, who carried out a lot of theory. And these students here have also been heavily involved. So I want to talk about topological plasmonics, and topology, of course, as you know, is about geometry. Many people talk about knots and windings and openings and so on. My topology is about skyrmions, and skyrmions is a concept that has been introduced to characterize three-dimensional vector fields. You see two different vector fields here on the left and on the right. Vector fields because you see these different vectors with their points being wrapped around a three-dimensional object. In this case, it is around a sphere. Now you see already that these vectors are wrapped differently around the spheres. And this left-hand topology is called a nail-type skyrmion, and the right topology is called a block-type skyrmion. So how can we classify such three-dimensional vector fields, which are very general, and what does it have to do with nano-optics? Imagine we are opening this sphere here. We are kind of cutting it open, and we lay it flat on the surface. But at the same time, we keep all the vectors in the same direction. So if we do this, if we cut it open, for example, here at the North Pole, then you will see these vectors point in a direction as you see down here. If we cut the right sphere open and we lay it flat on the surface, then you can see that these vectors orient as shown down here. And one can clearly see a difference between those two. Now, what does the term skyrmion have to do with this? Skyrmions have been introduced by Tony Skyrm in the 1960s as a purely mathematical concept in vector fields, and he tried